Now we need to talk about predicting products with double replacement reactions. We're going to do these 4 examples. I've got the solubility rules over to the side. We'll scroll over when we need them. Unfortunately, with these, you kind of have to decide what's made before you decide if the reaction happens or not. In a double replacement reaction, the 2 metal cations switch places. So calcium is going to go with nitrate. When we drop and swap, get our calcium nitrate. And silver is going to go with carbonate. Now we need to know silver's charge. But if we look, we know nitrate is -1, so silver must be +1. When we drop and swap those, we get Ag2CO3. Now we don't need to balance them yet until we determine if the reaction happens. So let's scroll sideways. There we go. In double replacement reaction problems like this, you can always assume that the 2 reactants are aqueous. You don't need to look them up. Remember we said that if the solubility rules say that it's slightly soluble, we're going to consider that as precipitating and causing the reaction. Remember, the reactions will not happen unless a molecular compound like water is formed or if something precipitates, because otherwise that's not a chemical reaction. You have to remember that if these are both in aqueous solutions, the calcium and the carbonate and the silver and the nitrate are all just floating around in water. And if something just makes more aqueous solutions, it's still just floating around in water. There is no net change. We need something to happen. So let's look at this first one. We have calcium and we have nitrate. So we should look through our list for something about alkaline earth metals, or calcium specifically, or nitrates. And you can see in number 2, it says most nitrates, chlorates, and acetates are soluble. So that means that this calcium is going to be aqueous. And then we have silver carbonate. So let's look for something about silver or something about carbonate. Nothing in the first line. Halides, but we're not dealing with a halide. Sulfate, not dealing with a sulfate. Well, sulfide, carbonate, phosphate, and chromate salts are only slightly soluble. We said that we could then consider that that would precipitate, and that would cause this reaction to happen. Here you can either put PPT for precipitate, or you can put S for solid. They both mean the same thing. It's not a big deal. So now we can scroll back over and work about balancing. If we want to balance this reaction, we need to put a 2 in front of our silver nitrate. And then we are balanced. So there's a few more steps in this. And those solubility rules take a little bit of time to kind of get used to using. But once you've got it, you're good. So don't worry, we'll keep practicing. Let's look at the second one. Our 2 metals are changing place. So barium is now going to be with nitrate. And if we drop and swap, we get BaNO3, 2. And copper is going to be with sulfate, but we need to know the charge on the copper. We know nitrate is -1, and there are 2 of them, so that gives us -2 total. So copper must be +2. So our copper sulfate will be CuSO4. Now let's check solubility. We already know that most nitrates are soluble. We used that the last time. So aqueous. And we want to know about copper or sulfates. We have over here that sulfates are usually soluble unless they're lead 2, mercury 1, barium, or calcium. And that's none of ours. So this is also going to be soluble. So that means this reaction doesn't happen. I'm going to put a big NR over here. No reaction. You don't need to balance it because it doesn't happen. Let's look at number 3. Our 2 metals are going to change place, and our sodium is going to pair up with nitrogen. So we have Na3N, and our aluminum and chlorine are going to pair up. And now we can look at our solubility rules. Sodium is an alkali metal, and the very first thing says that salts of alkali metals are always soluble. So this is aqueous. We have aluminum and we have chlorine. Chlorine is a halide, which you may remember having seen. Halides are soluble, except those with silver, lead 2, mercury 1, or mercury 2, which is none of these. So this is also soluble, which means that reaction 3 also does not happen. Let's look at one more example. Our lead and our hydrogen are going to change place. We need to know the charge on lead because nitrate is -1 and there are 2. Then we have lead 2. So we have lead 2 chloride, PbCl2, and hydrogen and nitrate make nitric acid. Let's go back and look. We just learned something about halides, so let's look again. Halides are soluble except silver, lead 2, mercury 1, and mercury 2. So we know that this is one of those excepts. Now we don't necessarily have to just determine about nitric acid, but you do know that most nitrates, chlorates, and acetates are soluble, and quite honestly, all acids that you'll see will be soluble. We should go back and balance. We're going to need 2 chlorines, and we're going to need 2 nitrates. And that should balance us out. So hopefully, the more you use these solubility rules, the more comfortable you'll get because you'll remember, oh, there was something about halides. Oh, there's something about sulfates, but there's exceptions I've got to check. So you just have to keep practicing, and it will get easier and easier. I've given you some practice problems below to check. Please test them and check your answers, and let me know if you have questions. There are also always practice problems you can find in your book. If you need help locating more practice, please just ask.